Welcome to the new episode of Into the Prods. In this video, I will be explaining you how did I solve one problem in a production grade system. So let me first clear out what is the idea of the app. So this app is basically an analytical dashboard viewing app, which like has sales data and inventory data of like multiple products of a specific company, where they are getting all of these data from multiple sources. So for all of the dates, they have multiple data. So as you can think, it's lots of data, like lots and lots of data. So we had implemented some kind of like outbox pattern, and like it was an event driven system, so user can uh, upload a file into the system, then a jobs gets included into our SQL table, and then a background worker will pull this jobs from our table asynchronously and then picks up the job, and then from a file it does some basic validations checking, and then after this according to our business logic, it transforms our data and inserts into the DB. And the whole process is like asynchronous, so user don't need to wait after uploading the file to get it gets inserted inside the DB. So it's an eventual consistent system. So this is the whole idea of our application, but the issue came day by day. Our data got increased, and then for monthly data records, it was taking hell lot of time to like fetch all of the data, like dashboard SQL queries. And we also have implemented indexes, as this is the first thing we try to solve when we are doing some optimizations in our SQL queries. But still, it wasn't enough, because on my queries there are lots of joins, like inventory table is separated, sales table is separated, and then I need to like join and then aggregate them, then the whole data is coming as in view. So it was lots of computations at the database side. So implementing indexes was not enough. Then I came across the Mendelian architecture. Mendelian architecture used on like ETL based structures or like in data lakes. It's more helpful. But also we are getting like lots of data, and it's analytical data, and most of our queries is like columnar based. So how to know the database we were using is like Postgres on the backend side. I know we could have used like columnar databases, but this is not the perfect solution. So after indexing, I get to know more about Mendelian architecture and how data analytics. This is a very important thing in data analytics, which helped me to improve our SQL queries latencies. So let me jump into the what Mendelian architecture is. So at first, when we are storing in a database, as you can see, there are three layers. Okay, bronze layer, silver layer, gold layer. Bronze layer is like your raw data, like whenever you have like CSV, XLX, PDFs. This can be any form of data. It's like unstructured data. This is the initial data that you get. So all of our clients, before uploading all of the files, they have their bronze data, and we are uploading it into S3, which is the bronze layer of our application. Then we come into the silver layer. So as I have mentioned earlier, every background worker picks up a job and then processes the whole file. Then it does some validation, and according to our business logic, it transforms the data into a table, right? And it did some kind of transformations according to our business logics and all. So we can like have inventory table and sales table. So this is the silver layer. But what I was lacking is gold layer. So the issue was the join and lots of aggregation, like right. My data was normalized way, and I was using lots of joins, and it was reducing the latencies. It was increasing the latencies. So what gold layer does is gold layer suggests create a data view which supports your business logic. Like let's suppose you need an analytical dashboard of like monthly data. For each month, you are storing that query's response as in whole. So you're pre-computing the value and storing it somewhere, and then when user like wants like last 5 months data or 2 months data, it will aggregate from all of the tables, and then it will show it to you. So it's less IO. It's using less IO overhead, because we don't need to check like all of the queries from all of the rows from our table. It has the pre-computed values as our views, and then we can aggregate all of these values and show it to the users. So this is the basically gold layer. Gold layer has all of the like the structured gold layer has the structured data according to our business logic. Whatever we need, whatever user wants to see, it stores exactly like as it is. And for my application, user was so the most of the queries were like show me the data from one day to another day. So I have created that gold layer table for a daily basis. So for daily basis, I had views. So in Postgres, we have materialized views. By using materialized views, we can have like all of the daily basis data. And for a daily basis, we have multiple rows of data, and now it's stored into one table as its own. And then from all of its views, I can select whatever day I want, and then I can fetch the data and show it to the users. Now it's quite fast, and I got a huge performance boost on this by using this. So Postgres supports materialized view, and there are lots of other databases also which supports materialized views. And even if you don't have materialized views in your DB, you can also use like gold layer tables. Like you can create those tables and you can store it directly to those tables. But as you can see, there are cons. So we are pre-computing everything into our database, right? So it's when we are pre-computing all of these data as in whole, it will take some overhead, which can also block which can create problems like deadlock and all. So we need to be very specific, and we need to also refresh this. So if we don't refresh it, user will be seeing like stale data. So what I am doing, I have this background worker which daily refreshes the materialized views for daily sales and inventory views, and it refreshes all of the rows and pre-computing the values daily, and then it shows to the user. So as I have mentioned, it's an eventual consistent system. So that's why this architecture supports goes along with my current business needs, and it worked pretty well. So now I'm showing you how I have implemented this. This is a basic demo application. It's not like it's just I have created it. So don't follow the code. Don't write exactly this code into production base. It's a very poor code written. For demo purposes, I have created this code. So as you can see, I have the Postgres available, and inside that I have my DB for like basic operation and table creation, and there I have creating all of this materialized views. So right now I have only sales table. If I go into my models table, there is right now only one sales table, which I'm creating in a DB, which creating all of these tables, and then after it creates the materialized views after creating the tables. Now we don't after initializing our database, no data will be there, so we need to ingest this. So then I have used this script. This is a basic script which is like inserting lots of data into our database. So right now I have ingested 11 million rows into our current database to show you how much it can affect our database. I have both of the queries available, like one query with the basic SQL query and one with the materialized views. If you go in my application, so this is a basic data ingestion script, and then if I go into my main script, I have one slow query. In slow query, I'm just using the normal select SQL command from the table, and I'm just showing it to the user. And then I have another fast query, which is actually have all of these pre-computed values inside my table, and it's just showing it to the users. So I have both of them ready, and after this, I will share this code with you guys, so you can like ingest this data, and then you need to initialize the DB. First, you need to initialize the DB, then you can ingest the data. Otherwise, it won't work. And before that, you need to also have Postgres available. So I have written a basic Docker compose app, and then you can run this main.py to run this application. So as you can see, this is the sales table. In sales table, I have all of the data for each date, and I have near about like 11 million rows. And then I have monthly summary, which is a materialized view of our table, which also I have created. This is the whole data. So it's quite less because we have pre-computed all of these values into this materialized view. And now what we need to do is like if we go into our application and just run this slow query. I'm running the slow query. As you can see, it's very much slow. It's giving us the response of total sales revenue amount, but it's taking like 1 second, which is quite slow. And if I run this fast query, this is taking so much less amount of time than the other, and this is showing the same exact results. So these are the things you can do to improve your performance, where you have like eventual consistent architecture, and there are analytical SQL queries. You can follow this architecture. It will help you a lot. Indexing not always be the answer. There are lots of other ways to fix it, but I guess after indexing, this will be the part you have to focus on. Like in software, when we are moving into solutions, we need to follow steps by steps. We cannot just jump into like another DB, another algorithm, another architecture just because our current support is not there. We can jump into similar. Okay, so and for also I have showed you that we need to also refresh our materialized view, so it can invalidate all of these current pre-computed values and recompute it again. So this API will help it. It will just refresh all of the materialized views, so user can see all of the latest values. And if I go into refresh view, all it's doing is like it's refreshing our materialized view of our sales monthly summary. So this is the whole idea of making this video. I hope this video helped you. Share it with your friends and colleagues. And also I would love if you want to give any feedback. I'm open for feedback. Feel free to suggest